Hello everyone, welcome back to my channel. This is Jess. So today we'll be looking at another LeetCode question called merge two sorted lists. So first let's take a look at the question statement. You're asked to merge two sorted linked lists and return it as a sorted list. The list should be made by splicing together the nodes of the first two lists. Let's now actually take a look at the constraints. The number of nodes in both lists in the range 0 to 50, and then the node values from -100 to +100. And the next constraint is very important. It says both L1 and L2 are sorted in non-decreasing order, which means that the order could be increasing, but it also could be two numbers that are the same that are listed together. Let's first take a look at the example. If you're given a list with 1 pointing to 2 pointing to 4 and another list of 1 pointing to 3 pointing to 4, if we want to merge these two sorted lists, the result would be 1 to 1 to 2 to 3 to 4 and to 4. So you're basically picking the smallest number of two lists and then put it in the result list and then keep going. Since these two lists are sorted, we are sure that the smallest number of all the nodes in these two lists are always going to be either the head of the list 1 or the head of list 2. So when we're trying to find the next node in our result linked list, which is the next smallest node of all the rest of the nodes in these two lists, we could just compare the heads of these two lists and see which one is smaller. For instance, for this example, we first look at the first two nodes of each of the lists and then compare and see which one's smaller. Since they're the same, we could pick either one of them and then put it in our result list. Say if we pick this one, and then we basically just remove this node 1 from list 2 and then continue. And then we compare the first node in list 1 with the first node in the rest of list 2, which is node 3. And then we see that 1 is smaller than 3. So we put 1 into our result list and then continue with the rest of the two lists. Compare 2 with 3, 2 smaller, so put 2 in the result and then take it away, compare the rest of list 1 with the rest of list 2. 3 is smaller than 4, put 3 in the result list, and now we're left with 4 and 4. So they're the same, doesn't matter which one you pick, put them in the result list. So the logic for solving this problem is fairly clear. We are comparing the first nodes of each of the lists and then decide which one goes first in our result list. And then we keep on comparing with the rest of the two lists and decide which one goes next in the result list. And to implement this, we could use recursion, because every step we're doing pretty much the same thing, comparing the head and decide which one to put in the result, and then move on to the next one in the two lists. For recursion, one thing that we need to pay attention to is to figure out when to stop. For this question, when do we stop comparing the two lists? That's when we don't have two non-empty lists, meaning that one of the lists is empty. That's when we stop, because at that time we could just put whatever list that's not empty to the back of our result list, and that's it for merging. So let's actually start coding this out. So let's start with our base case. If one of the lists is empty, so say if L1 is empty, then we just basically return the other one. Similarly, if L2 is empty, we just return L1. And then we're going to check the ordering between L1 and L2. L1 and L2 are the first nodes in the two lists. So say if L1 dot val is less than L2 dot val, then we know the smallest node of all the rest of the nodes that we're looking at is going to be L1. So we need to find out what's going to be following L1. And L1.next, we're actually going to call this function recursively right here. And we're going to pass in L1.next. So whatever's following node L1 in the first list, and then L2. Because L1 is already going to be in the result list, so for our recursive function, we're not going to look at it again. Instead, we're looking at the next node in L1. And right here, we're going to return L1 because we know that L1 is the current smallest node of all the nodes in these two lists. Similarly, in this case, that's when L2 has a smaller value. So we do L2.next equal to self.mergeToLists, and then pass in L1 because we didn't really add any nodes from the first list to our result list. Instead, we added our L2 node, which is the smallest node of all the nodes in these two lists for now. So we're passing in the next node in list 2. And then right here, we return L2. All right, so now let's talk about the runtime and the space complexity for this implementation. For runtime, since we're looping through all the nodes in list 1 and list 2, so the runtime is just going to be big O of m plus n. M being the number of nodes in list 1 and n being the number of nodes in list 2. And for space complexity, although we're basically just switching the .next pointer and merging the nodes, in this recursion function, when we return the final result, which is the head of the result list, in the stack there will be all the nodes from list 1 and list 2. So the space complexity for this solution is also going to be big O of m plus n. Alright, that's it for today. I hope you enjoyed this video. Feel free to try this out either on LeetCode or on your own. And let me know if you have any comments or questions in the comments section. And I will see you in my next video. Bye!